In this lesson, we'll look at modeling and solving one-step equations. This is part one of two. So this will just be the first part where we're solving just one step, very simple equations. So let's go through a couple terms here. So algebra involves using a variable, which we use a letter to represent, in the place of an unknown value. So example, y equals x minus 4. So we did see these types of equations when we were dealing with linear relations, and we can understand that x is the variable, y is also a variable, and those two variables represent unknown values. In order to solve for these types of equations, you need to isolate the variable. And by isolating, we get that variable on one side of the equation by itself. To isolate the variable, we will use the order of operations, but in reverse. So BEDMAS, but kind of in reverse. So instead of starting with like brackets, exponents, we're going to actually start with the adding and subtracting first. We will use what are called inverse operations. This is probably a new term for some people, in order to eliminate the number values. So we're going to get rid of the numerical values, the numbers, the constant values that are on their own, that are directly connected with the variable. And we will use inverse operations, which are just a fancy way of saying the opposite operation. So in this case, for part A, x minus 2 equals 9. The inverse operation of subtraction, because this is being subtracted, is adding. So the number, the constant that's directly connected with the variable, with the x, is a minus 2, or a negative 2. In order to get rid of that negative 2, we have to use the inverse operation. And this at the bottom here, I have remember to always balance equations. So you'll see this as you go on to in science, in chemistry. Whatever you do to one side, you must do to the other side. So whatever I do to this side, I have to do to the other side as well. So in this example, the inverse operation, we're going to get rid of that minus 2. The opposite operation of minusing or subtracting is adding. So we're actually going to take minus 2 and we're going to add 2. We're going to take the 9 on the left hand or the right hand side, and because we have to balance the equation, we have to add 2 to that side as well. So in a sense, when I subtract 2 and add 2, on the left-hand side, it gets rid of it, it cancels it because this actually equals 0. And so on the left-hand side, I'm just left with my variable x by itself. The minus 2, I've gotten rid of by adding it, and I have to balance the equation, so I have to add it to the other side as well. So I get a final value of x is equal to 11. The second example here, part B. The inverse operation, opposite operation, right now I have y plus 4 is equal to negative 12. In order to get rid of the plus 4, I have to think of the opposite operation of adding 4, and of course that is subtracting 4. And because I have to always balance the equation, I have to subtract 4 from the right-hand side as well. Both sides of the equal sign. So again, when I subtract, or plus 4 minus 4 on this side, subtracting 4 gets me to 0, which leaves me with just y, because that minus 4, or the plus 4 and minus 4 are now gone. And on the right-hand side, negative 12, or minus 12 minus 4, is negative 16. Be very careful with your integer adding and subtracting. It's very important in this lesson. The last example I have here, I just want to show you, because sometimes the constant number by itself that's not connected with the variable could be on the left-hand side. So in this case, the 8 is on the left-hand side, equals a plus 11. And so this a plus 11 over here, again, look at the value that's directly connected with the variable, that's plus 11. I do the inverse operation. The inverse of adding is subtracting, so I have to subtract 11. And then I'm also going to have to subtract 11 on the other side as well to balance the equation. So 8 minus 11, of course, is negative 3. This plus 11 minus 11 equals 0. You do not have to write this every time. I'm just showing you. And that's equal to a, which is my variable. And I'm done. So in these three cases, we had just simple ones, just one-step equations, adding and subtracting, and doing the inverse operation in order to isolate the variable, to solve for the variable. Okay, let's try some more examples here. Now these examples are going to be dealing with multiplication and division. We saw adding and subtracting. Now we're going to be dealing with the multiplication and division. So in the first example, part A, I have 10x, which we know is 10 times x, which is equal to 40. So because it's 10 times x, the inverse operation of multiplication is division. I'm going to have to divide by 10 by the value, the same value that's in front of the variable. And on the left or the right-hand side, I'm also going to have to divide by 10 because whatever I do to one side, I have to balance the equation. So on the left-hand side, when I divide a number by itself, this doesn't equal 0, it actually equals 1. And so what I'm left with on the left-hand side is essentially a 1 times x, because that 10 divided by 10 is 1. But we don't have to write 1 times, or 1x, because 1 times anything is just itself. So essentially it goes away. We don't need to write it. And on the right-hand side, 40 divided by 10 is, of course, 4. And that's what I'm left with. One-step equation, we divided because it was originally being multiplied, 10 times x, so we did the inverse operation, the opposite, which was dividing. Dividing by that value that's directly connected with the variable. Next, part B. So I have n divided by -4, or n over -4, over fractions is the division. Remember, every fraction is like a division question. And that's equal to 2. So the inverse operation of division is multiplication. So I have n over -4, and I'm going to have to multiply, and I multiply by the exact same value that's directly connected with the variable. In this case, it's -4. When I multiply by the same value on the denominator, if I multiply the denominator by a value of, say, -4, which is like -4 over 1, then what I end up getting is -4 over -4, which is again just 1. So it's very similar to the division. This -4 on the bottom multiplied by a -4 on the top, like I said, we'll end up getting -4 over -4, or just a value of 1. And that's equal to 2. And I also have to multiply that by -4 as well. So on the left-hand side, I'm left with just n, and the right-hand side, I get -8. Okay, so I multiplied both sides by -4. Another way to kind of look at it is to move things around, to multiply both sides, just to multiply by -4 on both sides, rather than having to write everything out to equal 1. That's okay too. The last example I have here is 14, which is equal to -2 times p. Opposite operation of multiplication is division, so I have to divide both sides by -2 in order to isolate the p. And again, -2 times, or -2 divided by -2 is 1. And 14 divided by -2 is -7. And that is equal to p, because I got rid of the -2. I eliminated them. Okay, so hopefully that one makes sense as well. Let's try these two on your own. So I'm going to give you a little bit of time now. Just try to look at them. You can pause the video, and then you can work on these two on your own. Maybe you pause the video. Now I'm going to show you how to do them. So if you still are working on them, please just keep it paused. But this is how you work on them. Okay, so subtract m minus 7. That's the number that's connected directly to the variable. So we're going to have to add 7 on both sides. -3 plus 7 is 4, a positive 4. And on the right-hand side, I'm left with just m. Number 2 here, this is w divided by 5. Find the variable first in the equation, and then figure out what number is it being added, subtracted, multiplied, or divided. In this case, it's being divided by 5. So I'm going to have to do the opposite operation, which is multiplication. And whatever I do to one side, I have to do to the other. So on the left-hand side, I get 30, and that's equal to w. So just two questions to kind of think about. When we add or subtract the same value, it cancels the value that was connected with the variable. Remember, we saw that. Why does this happen? Well, what happens is it ends up equaling or equals to 0, right? So we add or subtract that value to get rid of it completely, and we have to balance the equation as well. So recall to balance the equation, right? So whatever you do to one side, you do to the other side as well. Always remember to balance the equation. And lastly, when we multiply or divide by the same value, it also cancels out the value that's connected with the variable. Why does this happen? This time, it equals to 1. It equals to a value of 1, right? And we have to balance out that equation on both sides as well. So in the first time when we add or subtract, it equals 0. We get rid of it. In the second time when we multiply or divide to get rid of the number that's connected with the variable, it equals to 1. And because it's multiplied or divided, when we multiply by 1 or divide by 1, it just equals the same value, which is the variable. So hopefully that helps for this lesson. Again, this is part 1. So you can move on to the next lesson for part 2 and rewatch it if you get stuck.